Let's take a look at two things on this handout, the fundamental counting principle and combinations. Now, FCP, the fundamental counting principle, is a technique that we use when we're dealing with a problem that has a task with several parts. Remember when we had the ring and we had to choose the metal, and then we had to choose also the stone to go with this metal. So repetition may be allowed in some problems. Now let's take a look at combinations. For combinations, you use this technique, and the notation for that, for combinations, is NCR. NCR. So when do we use combinations? When repetition is not allowed. If you use somebody to do something, then they cannot do anything else in the problem. Then N is the number of people or things available. R is the number of people or things that are actually chosen or selected from the N available. And in combinations, order does not matter. That is what differentiates it from permutations. In permutations, order matters, but in combination, order does not matter. Let's now take a look at some problems on a particular handout. And those problems are a little bit more complicated toward the end. The first two are plain simple problems, and the other two are more involved, as you will see. I will go ahead and take a look at the first problem, then indicate the solution to the second one, and then I will solve the third problem in detail and give you an idea about the fourth one. So please listen carefully, and let's take a look at how we're going to solve those. The first problem is the following. An entertainment hall must select 12 of 25 possible entertainers for its summer schedule. In how many ways can that be done? So what we're going to look at is the following. First, is repetition allowed? No. If somebody is chosen, then they cannot be chosen more than once, okay? The second thing, do we have, what about order? Does order matter, yes or no? We are only selecting 12 people from 25 so that they can be part of the summer schedule. We are not assigning them a spot, saying that you'll be the first one, the second one, or the third one. We are not ranking them by saying that they're the best or or the second best or the worst. Basically, we are just choosing from 25 people in front of us, only 12 of them. So the order in which they are chosen, if I say Joe, Mary, Bob to start the list, or Bob, Mary, Joe, it doesn't really matter. So order does not matter. In addition to that, we have an N value. The number of available entertainers is 25, and an R value, the number of chosen entertainers, is 12. So what we're going to do here is we're going to use definitely combinations on this problem. So let's take a look at my answer over here for this problem. Repetition is not allowed, order does not matter, N is 25, R is 12. So we know we need to use combinations. With all those clues, we are going to use NCR, with N being replaced by 25 and R being replaced by 12. So we're going to go ahead and instead of N, we put 25. Instead of R, we put 12. Now, how did I get this answer right here? Let's use a calculator to get that. And let's go ahead and compute this information. So we want to type 25, go to math, highlight probability PRB right here, and then let's select over here the third option for combinations and enter the number 12 for the value of R. So N is 25, R is 12, and I'm using combinations. So the answer that I get is 5,200,300 different ways for us to select 12 entertainers from 25. Similarly, for the problem about Jenny with the CDs, read it carefully. You may want to pause the video at this time. What you will notice is that for this particular one, we have over here that repetition is not allowed, order does not matter, N is 9, R is 5, and you're using NCR with those values, and you have to type in 9C5, which I'll let you try. Let's take a look over here at the next problem, which is more complex, as you will see. From the 7 male and 9 female sales representatives for an insurance company, a team of 2 men and 4 women will be selected to attend a national conference on insurance fraud. In how many ways can the team of 6 be selected? So notice that in this problem versus the other ones that we did, we're talking about males and females. We don't just have one category of person, and I'll show that to you again. If you look at the first problem, you had 25 entertainers. You selected 12 from them. We were just dealing with entertainers. Here about Jenny, we had some CDs. She had basically over here 9, over here soundtracks, and she selected 5 soundtracks. So again, one category, soundtracks, just like here, entertainers. Problem we have here, we have to take care of the males but also take care of the females, so it's a more complex question, so you can expect something a little bit more involved for the solution. So let's go ahead and take a look at what's happening here. What I'm suggesting here is the following. If you were to go ahead and just focus on the males, you have 7 males representatives who are available and only 2 of them are going to a conference, okay? So what I'm saying is the following. If we just focus on the male sales representative in this problem, so forget about the female representatives for a second, it is a problem just like number 1 or 2 above. We observe something similar if we just focus on the female sales representatives for the problem. Take a look. We have 9 of them and only 4 will be going to the conference. So for each gender, we notice that repetition is not allowed. If I say, okay, Joe Smith, you're going there, I'm not going to call him a second time. And also, we notice that order does not matter. If I say Joe, Bob, Mary, okay, let's go, or Bob, Joe, Mary, let's go to the conference, it doesn't matter the order in which you say the names and you select the people. So because we have this, we also have an N value and an R value. All of this is calling for combinations to be used on each gender. You'll take care of the males using combination, and then you'll take care of the females using combinations as well. So just keep in mind, we have over here, since you are using combinations, you have N value for the males is 7. The R value for the males, how many are chosen, is 2. Okay, so 7 is how many are available, that's N. And how many are chosen, that's 2. And for the females, something similar. For the females, you have an N value of 9 and an R value of 4. Okay. So in addition to having combinations for each one of the genders, keep in mind, furthermore, since you are selecting 2 male representatives from the 7 male representatives who are available and selecting 4 female representatives from the 9 females representative available, this is a task that consists of 2 parts. You need to take care of the males and take care of the females so they can go to the conference. So to take care of that task with 2 parts, we're going to use FCP on top of the combinations that we use already for each gender. So what I did is I set up the problem this way. I had a little blue spot for the males and a little pink spot for the females. And now let's see what we have. I filled in each one of the spots. For the number of ways to select 7 males, the number of ways to select from 7 males, 2 of them to go to the conference, when order doesn't matter, I put a 7C2, entry for that, which we can compute in the calculator and find that this is worth 21 in terms of the value. And then about selecting the females, the number of ways to select from 9 females, 4 of them to go to a conference when order doesn't matter, is going to be 9C4. And that has a value of 126. So now we get 2 values, one for the combination computation for the males and one for the females, but we need to go ahead and decide what to do between those 2 over here. We need to use a multiplication symbol right here, just because FCP is going to tie in what we do to the males and what we do for the females over here. Okay, so that's the whole setup over here. And let's go ahead and enter what we get using the calculator. So let's say we wanted to enter a 7C2, which is a value of 21. So let me put that in here. So that's going to be 21. And then let's go ahead and put a 9C4, which is a value of 126. Okay, and we need to multiply those two together. Okay, so I need to put a multiplication symbol here, and that's FCP that I just used here to multiply the two numbers. And I do this, and then I time the two, and I'll get over here 2000, that it's equal to 2646 as an answer. So that's what I get for this one. So I hope this makes sense. You could have typed the whole thing all together. You could have done 7 over here, and then we wanted to do maybe the whole computation. 7C2 times 9C4. Altogether, if you did that, you would get an answer of 2646 indeed, but you would not have the in-between steps. So that's up to you which way you want to type it in. Okay. Now I will just quickly mention what can be done for the other problem, and I'll let you work things out for this one. We have the following: how many different committees consist of 3 teachers and 2 students? Let me read that. How many different committees consisting of 3 teachers and 2 students? Over here there's a of that should not be there. Can be formed from 11 teachers and 36 students. So the committee described above of 5 members can be selected in how many ways? So let's take a look at what I wrote for this one as an answer. And you can type it in the calculator. So basically what I have for this one, it's number 4. We have the professors, we have the students. So for the professors, we have 11 teachers and 3 are selected. So we want over here 11C3, and we wish to time that because we're using over here FCP, tie it to we have 36 students and 2 of them are selected, so that's 36C2. And when you use a calculator for that over here, you're going to get 165 timing over here 630, and the final answer on that will be 103,950. So that would be the answer that we get. Okay, so try this out and check that it's correct. And that's